Let's continue our lecture video series in engineering economics. So we have here compound interest. In calculations of compound interest, the interest for an interest period is calculated on the principal plus total amount of interest accumulated in previous periods. Thus, compound interest means interest on top of interest. Compound interest also reflects the effect of the time value of money on the interest. So as time goes by, so the amount of money increases. So here, we have here the cash flow diagram. So we have here compound interest on a borrower's viewpoint. So this is the present worth and this is the future worth in a specific span of time. The formula for compound interest is F is equal to P times 1 plus I raised to N, where the quantity 1 plus I raised to N is commonly called the single payment compound amount factor and is designated by the functional symbol F over P, comma, I%, comma, N. So this is the functional symbol. Elements of compound interest. The P there is present worth or the principal amount. F is the future worth or the compound amount. I is the effective interest per compounding period or per interest period, wherein I is equal to R over M. Then we have N, total number of compoundings. For N, we have T, or that is time or number of years of investment times M, which is the number of compounding per year. I is the interest earned, wherein future worth minus the present worth. Then R, we have the nominal interest, T, number of years, M, number of compounding per year. Now, here are the examples for nominal interest rate. R is equal to 12%. Given R is equal to 12%, let's differentiate the different time periods. The first one is, if the money is compounded semi-annually, so M here, or the number of compounding per year is 2. So that is for semi-annually. Wherein I here becomes 0.12 divided by 2, and then the N becomes 5 years multiplied with 2 for compounded semi-annually. For compounded annually, we have M is equal to 1, so that our I becomes 0.12 divided by 1. Then we have N is equal to 5 years times 1. So that is for compounded annually. For compounded quarterly, we have here M is equal to 4. That's why our I becomes 0.12 divided by 4. Our N becomes 5 years times 4. For compounded monthly, M is equal to 12. So the I becomes 0.12 divided by 12. And the N becomes 5 times 12. Then we have here compounded bi-monthly. So we have M is equal to 6. I becomes 0.12 divided by 6. And the N is 5 years multiplied with 6. For continuous compounding, need to remember this formula. F, the future worth, is equal to P times e raised to the interest rate of r times t, or the number of years. So for continuous compounding, interest may be compounded daily, hourly, per minute, etc. As a limit, interest may be considered to be compounded in infinite number of times per year. Okay, so that is for continuous compounding. Now let's differentiate the nominal interest and the effective rate of interest. For nominal rate, it is the rate quoted describing a given variety of compound interest. Now let's have this example. Consider a bank deposit of 1,000 pesos, so that is present worth 1,000 pesos. To earn 6% compounded quarterly. Now if we are compounding quarterly, m is equal to 4. So after 1 year, how is the future worth? Using this formula, we have here the 1,000 present worth, 1 plus the percent here, 6%, divided by quarterly, which is 4, and n is 1 year multiplied with 4. So the answer for future worth is 1,061.36 pesos. Notice that the interest earned is 61.36 pesos because originally our principal amount is 1,000, then the money grew into 1,061.36 in 1 year. So it says there that the interest earned is 61.36 pesos, representing what? This 61.36 is actually 6.136% of the 1,000 pesos and not the 6% of 1,000 pesos. For this case, 6% compounded quarterly is called the nominal rate and the 6.136% is the effective rate. Thus, the effective rate of interest is the actual interest earned in 1 year period, and this can be computed by either of the following figure. Number 1, we have their ER. So we have effective rate is equal to 1 plus the R here, the rate divided by the M. Either we are compounding quarterly, bi-monthly, so that is our M raised to M minus 1. Thus, the effective rate of 6% compounded quarterly is ER is equal to 1 plus 0.06. 0.06 is the nominal rate. And we have here for quarterly, 4 times 1 minus 1, so we get the value of 6.136%. For effective rate of compounded continuously, we have here ER is equal to E raised to the nominal rate R minus 1. So that is the effective rate. For equivalent nominal rates, from the previous discussion, we see that 6% compounded quarterly is not the same as 6% compounded monthly, for the reason that they have different effective rates. The nominal rates are equal if they have the same effective rates. Consider a nominal rate of 10% compounded quarterly. The equivalent nominal rate compounded with monthly is ER, subscript of M is equal to ER, subscript of Q, Then using the formula for ER, we will be having here the what's divided into 12, that is the monthly. So at this left side is monthly, at the right side is quarterly. So if we are looking for the nominal rate for monthly, so this is the answer. R is equal to 9.918% compared with the nominal rate for quarterly. It means that for the equivalent, for the effective rate to be equal for monthly and quarterly, the nominal rate for monthly should be 9.918%, and for the nominal rate for quarterly should be 10%. So for them they will have a equal interest or same interest. Now let's try to answer these examples. Okay. So we have here number 1. Accumulate 5,000 pesos for 10 years at 8% compounded quarterly. So first, let's have the given. So given here is the R, or the nominal rate, is equal to 8%, or that is 0.08. M here, compounded quarterly, is equal to 4. N, for the number of years, that is 10 years. And then P for 5,000 pesos. Okay. So what is now the future amount if the present worth is 5,000 pesos? Solution is using the formula a while ago. We have here the formula for compound interest for future worth is the formula P times 1 plus R over M raised to T, or we can have this as I raised to T. Okay, so we're in P here is 5,000 pesos. This is 1 plus the I here is the nominal rate of 0.08 divided by M, which is 4, raised to the time, which is 10 years multiplied with 4. So future worth here is that is 11,040.2. Okay, so that is 11,040.2 pesos. For number 2, accumulate 5,000 pesos for 10 years at 8% compounded semi-annually. In example number 1, we are considering here quarterly, but in example number 2, semi-annually. Okay, so we have here given, we have R is equal to 0.08, M semi-annually is 2, N is 10 years, present worth is 5,000 pesos. Future worth is equal to P1 plus I raised to T. So that is now equal to 5,000, 1 plus 0.08 divided by 2 raised to 10 times 2. So future worth is now equal to the question here is, which will have a larger amount, larger future worth? So here we have 10,955.62 pesos. So the larger amount here is the compounded quarterly. If we are having the same principal amount, compounded quarterly, it is bigger in comparison with the compounded semi-annually. Meaning, you are putting much more interest on the example number 1. You are putting more interest for compounded quarterly than the compounded semi-annually. Next, number 3. How long will it take 1,000 pesos to amount to 1,346 pesos if invested at 6% compounded quarterly? So let's put here the given again. Given here is the P, present worth of 1,000 pesos, given the future worth of 1,346. We have the nominal rate of 6%. So M here is quarterly 4. So how long? It's asking for the number of years. Okay, so let's use again the formula. F is equal to P1 plus I raised to T. And actually, this T here is N times M. So we have here F of 1,346 equals 1,000 pesos. 1 plus I is 0.06 divided by 4 raised to N times 4. So what is the value of N? That is 4.99, or that is 5 years. So that's how long you will have this money at this interest rate. Next, number 4. If the compound interest on 3,000 pesos in 2 years is 500 pesos, then the compound interest on 3,000 pesos in 4 years is, so we will put here again a given. So the given here is the present worth is 3,000 pesos. So our first year here, N1, is 2 years. In 2 years, the interest here is, the first interest is 500 pesos. And then it is compounded. So it did not mention, means we'll consider it as it is yearly. And then we have here N2, that is 4 years. So if we have here P, actually the presence of I here, we will be having the formula I is equal to the F minus P. So the future worth minus the present worth, and that is the interest here. So for the first one, for the 2 years here, we have 500 pesos, and that is equal to the formula here is, the future worth formula is 3,000 times 1 plus I. So we will put here the I. So we don't have any interest rate here raised to the power of 2 for the 2 years, then multiplied with 1 minus the present worth of 3,000 pesos. So in here, we will be getting a value for I, which we will use for solving the 4-year situation. So I here is 0.08, or that is 8%. Then we will be able to solve the next one. So the I here, I2 is question mark. So, future worth of 3,001 plus the I is given as 0.08, or we were able to solve for 0.08. This time this is n of 4 years times 1 minus 3,000. So what is the value for I2? So here the value for I2 is equal to 1,081.47 pesos. So this is the I4. So it means if in 2 years we have 500 here, then if we are looking for 4 years, multiplying 500 with 2 will give you 1,000 pesos. But no, this is not the solution. So as you can see, there is an interest or an extra interest of 81.47, because we're talking about compound interest, which means we are having interest over the interest. That's the reason why this is bigger than the 1,000 pesos. Next, number 5. What is the effective rate for an interest rate of 12% compounded continuous 1 year? So let's have the given. So the given here is the R of 12%, N of, well, continuous. Actually, it mentions they're continuous. So we will be having the formula ER. ER for the continuous is E raised to R minus 1. And that is E raised to 0.12 minus 1. So ER, or the effective rate continuous here, is 12.75%. So that is the answer for number 5. Continuous rate, effective rate. Next, number 6. An interest rate of 8% compounded semi-annually is how many percent if compounded quarterly? So here we are making comparison. An interest rate of 8% compounded semi-annually is how many percent if compounded quarterly? Let's put first the given. So the given here is, the first one, the first rate here is 8%. M, compounded semi-annually, so we have here 2. And then we have here, so this is M1, R2. R2 is equal to how many percent if compounded quarterly? So it is question mark. We're looking for R2. M2 is for quarterly 4. So we will be using the comparison of ER subscript of 2, or this is, so ER compounded semi-annually, so we are going to use is S, and then ER of quarterly, Q, sub Q. So ERS, we have here the formula 1 plus, so R for semi-annually is 0.08 divided by 2 raised to the power of 2 minus 1. That is equal to ERQ, we have here 1 plus R2 divided by quarterly raised to quarterly minus 1. So the answer here for R2, R sub 2, that is 0.0792, or that is R2 is equal to 7.92%. Okay, so that is for number 6. For the last problem, we have the number 7. The nominal interest rate is 4%. How much is 10,000 pesos worth in 10 years in a continuously compounded account? So there's the word again, continuous. So given the nominal interest rate of 4%, or that is 0.04. So we have here 10,000 pesos present worth. How many years? So we have here, it is asking for continuous compounded amount in 10 years. The formula for the future worth for continuous compounding is PERN, PERN. So present worth is 10,000 times E raised to R, which is 0.04, multiplied with 10 years. So future worth becomes 14,918.25 pesos. So that is the future worth if it is in continuously compounded amount.